So hello guys, now I'm Mathew Javier, a student of BS 82105. Now we're going to do a chapter 9 transport layer summary version 2.0. So now guys, let's go. So before we go into the summary, we will go backtrack about is the what do you call this? What is the background of chapter 9? So there I will say to you the section and objectives. So first is 9.1, subnetting an IPv4 network. Describe the purpose of the transport layer in managing the transport of data in end-to-end communication, and it also describes uh, characteristics of TCP and UDP protocols, include port numbers and in their uses. So the next is 9.2, addressing schemes. So addressing schemes explain how TCP and session establishment and termination process facilitates reliable communications, and explains how TCP protocol data units are transmitted and acknowledged to guarantee delivery. Describe the UTP client process to establish communication with a server, and compare UDP and TCP. So in transport layer protocol, so transport data, so it the role of the transport layer, it consists of responsible for establishing a temporary communications session between two applications and delivering data between them, provides connection oriented data streams, supports reliability, flow control, and multiplexing. And transport layer responsibilities also have track individual conversations, segment data and resemble segments, identify the application, conversation multiplexing, and segments data into small chunks, label data chunks accordingly to the conversation, transport layer reliability, and two protocols provided, TCP and UDP. TCP supports reliability while UDP doesn't. So guys, TCP, and it is support packet delivery confirmation. There are three basic operations that enable reliability with TCP: numbering and tracking data segments transmitted to a specific host from a specific application. You can also acknowledge received data, retransmitting any acknowledgement data after a certain period of time. So UDP provides the basic function for delivering data segments between the appropriate application with very little overhead and data checking, and perfect for applications that don't require reliability. So the right transport layer protocol for the right application. um, TCP is better for database, web servers, email, etc. And UDP is better for live audio or video streaming or VoLP or etc. So TCP and UDP overview. TCP features: establish a session, reliable delivery, same order delivery and flow control. And TCP header is a stateful protocol. TCP adds 20 bytes of overhead in the segment header. And go to UDP features. features is simple and fast. UDP header is stateless protocol. Reliability must be handled application. The pieces of communication in UDP are called datagrams. And data UDP adds only 8 bytes of overheads. So multi-separate conversations and transport requirements also has in there. So conversion by identifying this application, these unique identifiers are the port of numbers. So port numbers is usually seen in pairs source port and destination port. The source port is dynamically chosen by the sender. The destination port is used to identify an application and the server destination. So guys, there are also the socket and pairs, and IP address destination port number is known as a socket, and port numbers group, and the nestat command. So we proceed for 9.2 TCP and UDP. So the TCP and UDP process, communication process, TCP server processes. Each application process running on two server uses a port number. An individual server cannot have two services assigned to the same port within the same transport layer service. And we're going to the reliability and flow control. So guys, TCP reliability, ordered delivery. So TCP segments use sequence numbers to uniquely identify and acknowledge each segment and keep track of segment order and indicate how to reassemble and reorder the received segments. So guys, the same as the flow control, window size and acknowledgement, and TCP flow control function relies on a 16-bit TCP header field called the window size. And TCP source and destination agree on the initial window size when the TCP session is established, and TCP endpoints can adjust the window size during a session if necessarily. So the TCP flow control congestion advance. So UDP communication is also there. They are choose to TCP or UDP. So summary is that, guys, implement an IBB for addressing scheme to enable end-to-end connectivity in a small to medium-sized business network. Given a set of requirements, the implementation of implementation of a VLSM address scheme to provide connectivity to end user into small medium-sized network, and explains the consideration for implementing a IPv6 network. So next summary is that UDP datagrams and this I will go back from the start that UDP datagrams and segments have headers added in the front of data that include a source port number and destination port number. So these ports are enabled data to directed the correct application running on the destination computer. So data TCP does not pass any data from the network until it knows the destination is ready to receive it. TCP then manages the flow control of data and receives any data segments that are not acknowledged as being received at destination. TCP uses mechanisms of handshaking, timers, acknowledgement, manager, messages, and dynamically window to achieve reliability. The reliability process, however, imposes overhead or network in terms of much larger segments, header, and more network traffic between source and destinations. So if the application data needs to be delivered across the newly quickly, or if bandwidth cannot support the overheard control messages being exchanged between the source and destination, systems UDP would not develop a preferred transport layer protocol. UDP provides none of the TCP reliability features. However, this is not necessarily meant that have communication itself. So guys, the application developer decides the transport layer protocol that best meets the requirements for the application. So guys, it is important to remember that the other layers all play a part in data network communication and influence its performance. And guys, that is all for our summary for chapter 9, and thank you for listening.